Newton's laws and forces 2. Vertical net force. This is an elevator style problem. And we have no horizontal forces acting in this situation. We just have force applied now, instead of in a horizontal direction to the right, is going to be upwards. And that carrier of the force, the type of force, will be tension. So if you think of an elevator, it's got cables, and those cables pull up on the elevator. And let's even give this a coordinate system so that the positive direction is upwards. Okay, so we have that established. All right, well, here are the forces acting on the elevator. We will have the tension of the cable supporting this. So last time the supporting force came from the normal force, Newton's third law response force from the surface. In this case, it's just the tension cable pulling up. And we still have the force of gravity acting in the downward direction. So now, last time we saw pretty much it was like the force net was a competition between force applied and force resist, which could be friction or something like that. Now the competition is force applied in the upward direction against gravity. So that's sort of like the competition, and we'll see what happens. And the result is going to be the acceleration. It depends on which one wins here. All right. So let's think of this for a moment. Let's just calculate Fg, because that's going to be the same. It's the weight of the object, and so the weight of the elevator is the mass of the elevator times the acceleration of gravity. So what we have here is 100 kilograms times negative 9.8 meters per second squared, because that's the negative direction, and we get negative 980 newtons, like that. And I think what I'm going to do actually is write that below, give us a little bit of space over here. Can't find my eraser, so my finger is going to do the job just fine. In fact, that's a beautiful looking smudge, although I'm blocking it so you probably can't see it. No biggie. Negative 980 newtons. There we go. So we have three different situations here. What happens when the tension, the force applied, is 1200 newtons, which exceeds 980 newtons? What happens when force applied is exactly 980 newtons? What happens when it's less, 800 newtons? And in fact, I'll start off with pretty much scenario number 4. Well, what if we cut the cable? What's the acceleration? Well, that's pretty easy. It's a free fall situation. If there's no force applied, we know that the maximum this could accelerate downwards would be at negative 9.8 meters per second squared. So our gut says that whatever value came up here is going to be certainly less than 9.8 in the down direction, if it happens to be going down, or if it's going up, it's going to be like a very, very high amount of force if it's going to be greater than 9.8 meters per second squared upwards. But let's see what we got. All right. Well, to do this, I'm going to write down the second law equations. Newton's second law says that F net equals mass times acceleration. F net equals ma. In this case, we're looking at the y direction. Okay. So I like my y's with the little loopy so don't confuse my x's. So here we go. F net equals m times ay. All right. What is F net? Well, F net, again, is the sum of any of the forces. And we're looking for that leftover force. So it's called the sum of all the forces. This guy, as a reminder, this symbol here is capital sigma and represents summation. So it's the sum of all the forces in the y direction, like that, equals F net, and that equals m a y. Here we go, F net in the y direction, F netty. All right, what are the forces in the y direction? Well, we have force applied in the positive direction, and we have Fg in the negative direction, so minus Fg, like that. And so this together equals m times a y, like that. Okay, let's process this a little bit further. Let's solve this for ay. So the acceleration in the y direction would be force applied minus Fg divided by mass. So we've got this terrific setup here. Because we have three different situations, it's very easy. I don't have to plug in numbers until the very end, and I've got this piece over here. I could even use this formula in something like Excel or Logger Pro to model the behavior, and I could choose any arbitrary force applied and then get a result, which is cool. I could even change Fg, and this is still all good. So let's just do it by hand though. So the first one, AY1 is going to be 1200 newtons, which is the force applied in this situation, minus Fg, which is 980. I didn't do a double minus. Remember, this is already negative, and so that's what happens over here. This negative is already because of the fact that it's in the downward direction, okay? So we don't double negative that. And divided by m, which is 100, all right? And let's see, well, we got 1200 minus 980, that's 220 divided by 100. So it's 22 over 10, or 22 tenths, 2.2, I think. Is that right? I think so. Yeah. Absolutely. It's a little late, guys. My mind isn't doing the simple math all that well, but here we go. We got it. 2.2 meters per second squared. It's positive, upwards. All right, AY2 is 980 minus 980, and well, we know I could write, why not, divided by 100, but we know that this is 0 meters per second squared. All right, I'll box in these results so that we can see them better. That makes sense. If you have the same amount of force up as down, they cancel each other out. And so we have no acceleration. That doesn't necessarily mean the elevator is not moving. Remember, it could be moving at constant velocity due to Newton's first law, or it could be at rest. But so maybe it's just coasting up or down. But we don't have an acceleration that's changing its state of motion. Therefore, all we can say is that with this 0 meters per second, it's either moving at constant velocity up, down, or it's standing still. And those are the three possibilities. And it would depend on the situation that came before it to determine what that is. Lastly, AY3. Well, now we've got 800 minus 980 over 100. And that is 180 over 100, or 18 over 10, which is negative, I should say, 1.8 meters per second squared. All right, so we see that if the tension is lower than gravity, the acceleration is negative, which means that this is changing its motion, so it's accelerating in the negative direction. It's gaining speed downward. So we can definitely tell in the first case the elevator is rising. In the second case, we can't tell if it's rising at a standstill or if it's moving downwards. It's just at constant velocity. It would depend on what's happening beforehand. If this came first, then we might say, oh, okay, it's probably moving upwards at constant velocity. And here we clearly have a negative acceleration, which is a downward motion. The elevator is accelerating downwards, gaining velocity in the negative direction, down. And that's what it is. All right, so that's what it is. Sum of the forces in the y direction in this case. Last time it was sum of the forces in the x direction. And I'm wondering if I wrote it as sum of the forces F net, which doesn't make any sense. But it should have said sum of the forces in the x direction in the last video, where we do it with the horizontal. And I think I did, well, I wrote it F net x or something like that. But really, it's the sum of the forces in whatever direction we're analyzing. In this case, y, in the other case, x. All right, so I hope that this is clear. I'll get out of the way so you can look at what's going on here, since we only have one board. Take it down. Yum, yum, yum. All right, you could have paused it beforehand. Hey, I'll get out of the way again. Huh. Ah, and that's what it is. All right, we're done. Morad, out.